if you plug x in right there, that number right there, you can then solve for y. You know, square it, take 1 minus the number, and then square root it, and you'll get y, which has to be positive, obviously. In my case, I think I got 0.5773 when I did that, or 0.577. Okay, problem 8 then gives us the surface area of a sphere and wants us to find the volume. So the surface area is 4 pi r squared for a sphere. The surface area in this case is 181 pi. So we're going to solve for the radius and plug it into the volume of the sphere, which is 4/3 pi r cubed. So don't forget to cancel these pi's on both sides. A lot of times students forget to do that. Divide by 4, and you get r squared equals 181 over 4. Square root both sides, and that gives you r. And we're going to plug that in right here. So it's going to be 4/3 pi square root of 181 over 4 cubed. Now, I just put the 2 in the bottom probably because that square root is really a 1/2 power. So as long as you enter that in here or evaluate this in your calculator and put the right decimal there, keep in mind 3 decimal places probably at least should give you the right answer. Okay, the next problem gives us the volume of the cylinder is 87. We know volume of a cylinder is, the formula is area of the base times the height, where the base is pi r squared. I'm going to write that formula down. And then they give me a relationship. They say the radius is twice the height. And they want me to find the surface area. So I'm not going to do this whole problem, but I'll just give you the what you should do. If you plug in an r to get rid of this from this equation, you'd have 2h squared times h. Now this equation allows you to solve for h. Obviously it turns into 4h cubed if you square both these and then multiply by h. And then you can just solve for h right there. Then you'll have h and r, because you know that you just, if you have h multiplied by 2, you get the radius. Now for surface area, then you can just do the surface area formula for a sphere, which is perimeter times height plus 2 bases. The perimeter is 2 pi r, the height is h, and the area of the base is pi r squared. So if you're trying to find the surface area, they use this equation. You'll now have r and h from solving this, and you'll get a numerical value you can enter in there. Okay, the next problem says that NASA launches a rocket at t equals 0 seconds in height. And here's the height equation in terms of time. It's going to be a parabola that opens downward. So the first question says, assume the rocket will splash down in the ocean. At what time does the splash occur? Keep in mind this is time, this is height, so we're looking for that time, so that x value from the function, which we can get from the graph, or we can get from plugging in 0 for h. Plugging in 0 for h, we get negative 4.9 t squared plus 322t. You get the idea, plus 94. And you solve for t using the quadratic formula or whatever method you want. I'm going to get that from decimals because I'm in a hurry here. Then find the maximum height, which is the y value of the vertex. I'll get that from decimals too, but keep in mind you can always do the x coordinate for the vertex is always negative b over 2a in your formula sheet. Once you find that t for the maximum height, plug that into back to the function, and that will give you the maximum height. So I'm just going to get those some decimals real quick. If you graph this thing, you can change your axis, by the way, to look a little bit better if you want, because my x-axis is a little too big here. You can see. So I'm just going to go from like negative 200 to 200 or something. So you can just type that in, and that does help a little bit, hopefully. So we're looking at 66 seconds for when it hits the ground. And then the maximum height is the y coordinate for this point up here, which is 5,384. Okay, the next question says that we have an equilateral triangle. It gives us the area. So first draw a picture whenever you're doing a problem like this. Try to draw your best equilateral triangle. Area is 117 equals, now it's 1/2 base times height for the area of the triangle we'll use. There's other formulas we could use for area of the triangle, but we'll use this one. Definitely other ways to do this problem. Now, the base, I'm going to call these sides x, because they're all the same. So it's 1/2, the base would be x. I'm going to get the height in terms of x now, so I'm going to draw the height in here. Now we know that this is a 60-degree angle, so that would make this a 30-degree angle. So we have a 30, 60, 90 triangle. You can use Pythagorean theorem here if you want, but I'm just going to use my special right triangles to know that The small leg is always, whatever the small leg is, the hypotenuse is twice that, and the longer leg is this times the square root of 3. So that'd be square root of 3 times x over 2. That's going to be that if you do the Pythagorean theorem as well. So that goes in right here for the height, the times x times the square root of 3 over 2. So this turns into 1/2 x squared. I guess it'd be, if you multiply the 2's, you get 4, and 1 times the square root of 3 is the square root of 3. So if you just multiply everything in the top order, doesn't matter, you get this. Solve that for x. Once you find x, keep in mind that it asks for perimeter, and perimeter is going to be 3 of those x's, right? You get the whole perimeter. So once you find x, plug it in here, that'll be your answer. Okay, the next problem says the width of a rectangle is 1 less than twice its length. So the width of the rectangle is 1 less than twice its length. That would be that equation. And then it gives us the area is 174. Now we know that area is equal to length times width. So we have two equations now with two variables. I mean, it might help to draw a picture. Just always draw a picture. It's a good idea. They're actually looking for the diagonal though. So this would be width, this would be length. You're looking for that. That's your answer right there. So solve this system of equations. Once you get L and W, do the Pythagorean theorem to find the hypotenuse. So it's simple substitution. Just substitute that in right there. 174 equals length times 2L minus 1. Solve for L. Once you get L, obviously you have W, and then do the Pythagorean theorem. Okay, the next problem says you have a wire that is 62 centimeters long. So the length of this wire is 62 centimeters long. You wish to cut it in two pieces. One piece will be bent in the shape of a square, and the other piece is going to be bent in the shape of a circle. Okay? It says let A represent the total area of the square and the circle. So we have A equal to the area of the square plus the area of the circle. What's the circumference of the circle with minimum area? Okay, well first I'm going to have to define some things. I'm going to call the side length of the square x. I'm going to call the radius of the circle r. That way I have some variables that I can use. Okay, so the area, the function we want to minimize, is going to be the area of the square, which is x squared, plus the area of the circle, which is pi r squared. Another equation I can write is, since I only have 62 centimeters, then another equation would be 62 equals the perimeter of the square, which would be 4x, plus the perimeter of the circle, which would be 2 pi r. So now I've got two equations. I can solve this equation right here for x, or r even. Let me solve it for r and plug in here. So then I'll get an area formula in terms of just x. So that'd be r. I need to solve for r, so that I'd subtract 4x from both sides. And then I would divide both sides by 2 pi. And that goes right here. And that'd be squared. So this is now, what I've got here is an area formula in terms of x, which I can graph. I don't know what it looks like, but there's some minimum value somewhere in there, a local minimum, that I'm looking for because they want me to minimize the area. So I'm looking for that minimum point. Once I find that point, let's say it's 2 comma, I don't know, 4,000. The x value is what I want there, because I'm going to plug x back into this equation right there. I'm going to find the radius, or I'm going to find actually this, because they asked me for circumference, which is the circle, which is right here. So once you find this x value, plug it in right here, and then subtract from 62, divide by 2 pi, and subtract 4x from both sides right here, and you'll get your circumference right there, which is what they asked for. Okay, let's end the homework with just a couple completing the square problems, because I'm going to have to check your work on this and make you guys do this in the test. So the expression right here equals this if you complete the square, which basically puts it into vertex form. So when you complete the square, what you want to do is you want to get the c term to the other side. Now you want to make sure that a is 1. Since it is, what I can do now is just add b over 2 squared to both sides. So it's 6 over 2 squared to both sides. Now 6 over 2 is really just 3. I usually leave it like this on the left side, but on the right side it's really just 9 that I'm adding. The reason I leave it like this is because it's real simple to take this value, put it here, this value, put it here, because it's a perfect square trinomial. And then it's pretty easy to solve from here. They wanted it like this, so it's x plus a squared, and then I can move this over to the other side, which would make it plus 120, you know, equals 0 basically. But they want it in this form right here, which is actually vertex form. If you had this right here, vertex form is y equals a x minus h squared plus k. So by completing the square on this and then moving the c term back over right here like this, you get into vertex form, which is what they want. A in this case is 3, and b in this case is 120. Let's try it one more time. But I like this format a little better because they set it equal to y for us, and it's a little harder. Complete the square on this one. So I need to get the 15 over to the other side, in which case I have this. I also need to, before I add something to both sides to make this a perfect square trinomial, I need to get a to be 1. So I'm going to divide by -5, and I have to divide everything through by -5. So I'm just going to put it over here like that for now. Actually, no, I'll divide both of them in. So it's -5 plus 3 equals x squared plus 14. Now I can complete the square by adding b over 2 squared to both sides, which is 14 over 2, which is 7 squared, which is 49. So I'm going to add 7 squared to both sides. Over here I'll just add 49. So I get this. I get negative y over 5 equals x squared plus 7, x plus 7 squared rather. And then negative y over 5 plus 52, I forgot 3 plus the 49 right here, equals this. Alright, now I can subtract 52 from both sides. And then I can also multiply through by -5 now. That cancels the negative and the 5. Multiply through by -5. Don't forget to do it to both terms. So your final answer is -5 times x plus 7 squared plus 5 times 52 would be 250, so 260. There is my parabola in vertex form now, where I know what a, h, and k is. If you compare to standard form, a, x minus h squared plus k, it's not hard to see what a is. H is a little trickier because it's got to be -7, so that the double negatives will cancel and go positive. So h is actually -7, and then k is 260. All right, I hope this helps.